Hey everybody, this video is going to go over the multiplication strategy for 2 by 2 multiplication, how to do 2 by 2 multiplication using the area model. Okay, so this is one of three strategies we're going to be using in class. I will put up the other two videos once we go over them in class, but this specifically is to show you how to use the area model. Again, it's important that you understand how to use all three of these strategies, but it is okay for you to have one that you like better than the others and one that you go to when I'm not requiring you to do one or the other. But there will be times when one is just better than another for solving a certain type of problem, or when we might do a knowledge check to make sure that you understand how to do all three. So it's important that we understand how to use all three of the strategies. So jumping right in, first thing is we already went over the strategies for doing 2 by 1 and 3 by 1 multiplication using a area model. So this is building off of that. If you haven't been in class or you haven't seen the videos that I've put up showing the 2 by 1 and 3 by 1 using an area model, go back and review that, because we're not going to cover every single thing about how to set up the entire area model. We're going to build off of that. So without further ado, when we are doing 2 by 2 multiplication using an area model, we start by creating our model itself. Well, first, let's just name a problem. Let's say we're going to do 32 times 54. Okay, so 32 times 54. So 2 digits times 2 digits. So we first start by drawing our area model. And because it's 2 by 2, it's going to look a little bit different than it does before. It's going to have 4 areas, okay, for 4 partial products, okay? And if we remember, with the other forms of the area model that we used, we also broke things into expanded form. Same thing when we are doing it with 2 by 2. Now, because it's multiplication, it doesn't matter whether we have the 32 on the left or the 54 or vice versa. Either way it works, but we'll just show this. We'll say we'll put the 32 on top. So we break that into 30 and 2, which is the expanded form of 32. So we label 30 and 2. And then on the left, we'll have 50 and 4. Okay, now notice the size of these boxes is supposed to correspond to the relative size of the partial product, okay? Meaning the 4 times 2 would be in the smallest box, the 50 times 30 in the largest, just giving you a visual, thinking about it as the area of something. And from here, what we do is we multiply where these numbers cross. So 50 times 30 crosses in this box, and that's where we'll do it. 30 times 4 here, 50 times 2 here, and 4 times 2 here. So if we're working it out, and we've labeled it correctly, think of it as 5 times 3 is 15, but it's 5 tens and 3 tens, so it's 15 hundreds, or 1,500. Now, it doesn't matter which order we do it in, okay, as long as we're doing the correct numbers that we are multiplying. So we'll just do 50 times 2 here, because it's where they cross. 50 times 2, well, 2 50s is 100. 4 times 30 would be here, 4, 30. 4 times 3 is 12, but it's 12 tens. And 4 times 2 is just 8. Once we have these 4 numbers, we just add our partial products, or in other words, our products that are in each of these 4 boxes. So you have 1,500, 120, 100, and 8. We add these up. 8, 2, 5 and 1 is 6, plus 1 is 7, 1,728, giving us our answer. Okay, so just like the area model with 3 by 1 or 2 by 1, we find our partial products and we add them together to get our answer. So let's do another one. Okay, let's do, and I want you to solve this one yourself. I'll give you a second to pause the video and work it out, and then we'll go over it together. Let's do 63 times 29. 63 times 29. So I'll pause myself for about 5 seconds, let you pause the video. You can work it out, do your best, and then we will come back and work this through together. All right, so hopefully you were able to work this out, but let's do it together, okay? So we start by, so that's 63 times 29, we'll start by creating our area model. So we break it into 4, okay? And we'll label this 60 and 3 and 20 and 9. And again, if this was 20 and 9 and 60 and 3, it would still work. It doesn't really matter which one is which. It's just however you plan on labeling it. Now notice, it wouldn't work if it was 60 and 20 and 9 and 3. You need to have one number split into expanded form, labeling one side. Okay, so this is 63 times 29. And from here, we multiply where they cross, get our partial products, and add them together. So 20 times 60 is the same thing as 2 times 6, or 12. Tens, tens, so 1,200. 20 times 3, well, 20, 40, 60, or 2 times 3 is 6 with the 0, so 60. 9 times 6. And just remember, if you are having trouble with your 9s, think about what 10 times 6 is, or 60, and take away 1 6, so that's 54. 54 tens. And 9 times 3 is 27. Okay? Now we add up our partial products, 1,200, 540, 60, and 27. And one thing I just want to say, this is just something to help make sure you don't make any mistakes that you wouldn't normally make. Try to do your numbers largest to smallest when you're adding them up like this. It just prevents errors with place value. Okay, it just makes it a lot easier to work out. Notice I have the 1,200 on top, followed by the 540. Otherwise, you can end up with just some issues. Okay, so nothing plus 7 is 7. 4 and 6 is 10. Plus 2 is 12. Put our 1 up there. 3 and 5 is 8. And we drop down our 1, giving us 1,827. So again, everybody, this is just one of the strategies that we will be doing in class. We will learn 2 more over the coming days, okay? A great way to double check your work is to use a different strategy, but since we haven't gotten into those, you can check using a calculator for right now. But once we learn how to do the standard algorithm and a lattice, a great way to get familiar with all of them is do a problem with the way you're most comfortable with, then check it using another way, okay? Again, if there's any questions about this, please just make sure you post it in the classroom or ask me in class, or you can shoot me an email, and I will see you all in class. Thanks.